This is worksheet 21.4, and we're going to look at number 2 and 3, which uses the formula for compound interest. So we're going to use this formula right here. So in number 2, we're going to define what each of these parameters represents. P is your starting value, or we call it the principal amount of money. In this formula, R is the interest rate. And we always want to write the rate as a decimal. N represents the number of times that the interest is compounded. That means the number of times every year that the bank will give you interest. T represents the amount of time. So in number 3, we're looking at a table where the frequency is changing. The frequency that the interest is compounded goes from quarterly to monthly to weekly and so on. So we're going to look at a couple of these as examples to see what happens to the final value of the account as we increase the frequency that we're compounding in. So let's start with quarterly. Quarterly means 4 times a year. So if we do this problem and use the compound interest formula, I'm going to do the quarterly row. N is the number of times per year, so that means 4 times per year. P is the principal, or the starting amount of money. In this case, Mr. Faberabel has invested $10,000. R is the interest rate, 4% annual interest. If we change that to a decimal, that's 0.04. T is the amount of time. Here we're told that it's a 10-year period, and what we're trying to do is find the value of the account. So I'm going to use the compound interest formula. P in this problem is $10,000 times 1 plus, the interest rate is 0.04, but we're going to divide by the number of times, which is n, so divided by 4, to the exponent of n times t. So up here we have 4 times 10 years, which would be a total of 40 times. So in your calculator, if you wanted to type that all in at once, make sure you use enough parentheses so that your calculator knows the order of operation. So 10,000 times 1 plus 0.04 divided by 4 in parentheses. Another parentheses to the exponent. 4 times 10 is 40, and so you end up with $14,888 and 64 cents. So I'm going to go ahead and skip in this chart to what would happen if we were to have interest compounded hourly. So we know there's 365 days in a year, 24 hours in each day, so that's 8,760 hours. In the rest of the table, we still have $10,000 as our starting amount. We still have an interest rate of 4% and a time period of 10 years. So if we calculate the amount of money based on the hourly option, we're still using the same compound interest formula. So $10,000, 1 plus R is still 4%, but now N, we're dividing by 8,760 hours. And then up here, we're multiplying 8,760 hours times the 10 years. So again, in the calculator, I'm going to go ahead and type that in. So we have $10,000, 1 plus 0.04 divided by 8,760, and the exponent is 8,760 times 10, so 8,760, and add another 0 under that. So we end up with $14,918.23. So the last one I'm going to do, just so we can see what's happening to this final value of the account, is the minute. So if we do 8,760 hours times 60 minutes, you'll end up getting 525,600 minutes. These end up staying the same, so $10,000, 4% for 10 years. If you're using a graphing calculator, you can use second enter to just pull up the last entry. I'm going to go back and change my N. So I'm going to delete that and insert the new N value, which is 525,600. And then I'm also going to change this I'm doing 525,600 times 10. So I'll add another 0 onto that. And you end up getting $14,918.25. So what you'll notice here, now that we're done with hourly and by the minute, is as you increase the frequency of how often the bank is compounding your interest, the total value of the account ends up not really changing much. It's only changing by 2 cents whether they do it every hour or every minute.